Lesson 16. Solve problems with equations. Let's look at the lesson objectives, the content objectives. Students will be able to solve problems involving rational numbers. Students will be able to convert among fractions, decimals, and percents as needed to solve the problem. Students will be able to estimate the reasonableness of answers. Students will be able to solve word problems leading to equations of the form p times x plus q equals r and x plus q times p equals r, where p, q, and r are integers, fractions, or decimals. And lastly, students will be able to solve using estimates for the fractions and decimals first in order to get an estimated solution. Let's look at the language objectives. Remember, this is again, I can. You should be able to say by the end of this lesson, I can summarize information about how to solve a two-step equation. I can describe steps for solving two-step equations that involve fractions using the terms constant, coefficient, and variable. I can compare models for solving multi-step problems with decimals and explain the similarities and differences orally to a partner or small group and in writing. I can articulate different ways to solve multi-step problems involving decimals and fractions. The prerequisite skills: fluently compute with rational numbers, convert among forms of rational numbers, estimate, discuss reasonableness of answers, solve one-step equations. There is no new vocabulary for this lesson. The learning progression. In grade 6, students solved one-step real-world and mathematical problems leading to equations of the form x plus p equals q and p times x equals q, for cases where x, p, and q are all non-negative rational numbers. In this lesson, students solved multi-step problems leading to equations of the form p times x plus q equals r and x plus q times p equals r, without the restrictions they had in grade 6. In grade 8, students will solve real-world and mathematical problems leading to one linear equation and two linear equations in two variables. Let's use what we know. You know how to compute with rational numbers and write and solve one-step equations. Take a look at this problem. Mr. Lombardo took his two children to a water park. He used the coupon shown below to buy one adult ticket. The price of admission for all three family members was $76. What was the price of each child's ticket? So let's look at that coupon. This coupon is good for one adult ticket to World of Water at a price of $28. You save $4. We're going to use the math you already know to solve the problem. Question A. What ticket price do you know? How much is the ticket? Explain your answer. Question B. What other information is given in the problem? Question C. How can you find the price of the two children's tickets? Show how to find your answer. And question D. What is the price for each child's ticket? Show your work. So pause this video, see if you can solve these 4 questions, and then check your answers once you unpause. Well, let's look at question A. Question A says, what ticket price do you know? How much is that ticket? Explain. Well, you should know that Mr. Lombardo used a coupon that says the price for an adult ticket is $28. That was given right here. This is the coupon. Okay, it's $28. Question B. What other information is given in the problem? Well, we know that the price of all 3 tickets is $76. So think about that. Okay. Question C. How can you find the price of the 2 children's tickets? Show how to find the answer. Well, Think about that. Subtract the price of the adult ticket from the total cost to find the cost of two children's tickets. So, we know that in total it was $76, and then you take away the $28, right, that an adult ticket is with that coupon. So now you're left with $48 when you do 76 minus 28. So think about that. If the total price now is $48, what would the price for each child be? And since there's two, you do 48 divided by 2, and you get $24. So the answer to that question is each child's ticket costs $24. Let's find out more about this problem. Think about that. You can also solve the problem from the previous page by writing and solving an equation. You know that, first of all, an equation has an equal sign in it. You should know that. So the equal is the total. In this case, it'd be $76. But let's look at this. You know that the price of the adult ticket plus the price of two children ticket is $76. So look how they wrote that. The price of the adult ticket is $28 plus the number of children, which is 2, times the price of child's ticket. Can you guys see that? All of them combined should equal $76. Okay? You can write this as 28, right, plus 2 times p, 2p, equals 76. All of these equals 76. This equation includes 2 operations. So it is a 2-step equation, and we'll break it down why it's 2 operations. Okay? Solve the equation for p and compare to the operations used in the arithmetic solution on the previous page. So there's the equation. 28 plus 2p equals 76. So the first thing you do in this problem, and we will go over that with using a flowchart as well, you would take 28 away from both sides of the equation. Because what you need to do is do the inverse of order of operations to solve equations. Okay, so we know order of operations tells us to multiply first and then to add. But because we're doing the inverse of order of operations to solve for the equations, we're going to subtract 28 from both sides of the equation. 28 minus 28 is 0. 76 minus 28 is 48. And now you got to ask yourself, 2 times what equals 48? So you're going to divide by 2, because the inverse operation of multiplication is division. So whatever you do to one side of the equation, you must do to the other. 2p divided by 2 equals 1p, because 2 divided by 2 is 1, and then you're left with that p. 48 divided by 2 is 24. Therefore, the answer is 24, and it's also written here. Using arithmetic, the first operation was to subtract the price of the adult ticket from the total cost. In the equation, subtract 28 from both sides and simplify. So there it is. Okay, notice it's in red as well. The second operation was to divide the price for 2 tickets, $48 by 2, to find the price of 1 ticket. In the equation, divide both sides by 2 and simplify. To solve an equation, you perform operations so that the variable ends up alone on one side. Remember, the expressions on opposite sides of the equal sign are equivalent. If you perform an operation that changes the value of the expression on one side, you need to perform the same operation on the other side. That's why they have an equal sign. But let's use flowcharts with this. So our equation, oops, take that back, my bad, 28 plus 2p equals 76. Okay. Flowcharts. We're looking for the value of p. We're going to put p equals. What happens to p first times 2? Then what happens to it? Plus 28. Not because of this positive, but because of its positive 28. And the output is 76. Let me use a different color actually. Now let's backtrack. I just set it up. 76 minus 28 equals 48. And then the inverse of multiplying by 2 is divide by 2. 48 divided by 2, 24. Hopefully this makes sense. If not, I would go back in this video and re-watch that.